All right, we are here to learn how to add and subtract rational expressions, and then we're going to also look at how to simplify complex fractions in this video. And so this is part 2 for my class, is lesson 5.3. So we are looking at this example here. You have x minus 3 over a trinomial, x squared plus 3x minus 4, and we're going to add to that 2x plus x plus 4. So first thing we need to do is we want to find the least common denominator. So what we want to do is we want to factor each denominator here. And so this is going to factor into x, and factors of negative 4 that add to positive 3 would be plus 4 and minus 1. So my I'm going to rewrite that. I have x minus 3 over x plus 4 times x minus 1, and I'm going to add to that, the right side, 2x over x plus 4. So let's look at, we have to have every factor show up in the least common denominator to the highest power. So we have, over here, we have an x plus 4. That needs to be part of my denominator, and we have an x minus 1. And then on the right side, we have an x plus 4, but we already have that in our denominator, so I don't need to put that in there again. So if you look on the left side over here, this already has x plus 4 times x minus 1 as a denominator, but on the right side, we are missing, from the denominator, we're missing this x minus 1. So I need to multiply it over here on the top and on the bottom. You got to do the same thing on the top as you do on the bottom. X minus 1 times x minus 1. And then I'm going to, get rid of that circle. I'm going to, now I have a common denominator, so I'm going to add the numerators and keep my denominator. That's why we found a common denominator, so we can add the expressions together. And you can only add fractions that have common denominators. So then I'm going to add the numerators together. So I have, right here, I have x minus 3. I'm putting it in parentheses so you see where it's coming from, but you don't need to put those in parentheses because it's all addition, plus 2x times x minus 1. So this numerator, adding the numerators together. Now I want to simplify the numerator, and I have, in the denominator, I'm going to leave that, so I'm going to put that back down here. And I'm not going to distribute that because I'm going to want to simplify things here in just a bit. So on the top, I have x minus 3 plus, I am going to distribute here because these are not factors, and the denominator have x plus 4 and x minus 1, those are both factors. In the top, this is not factors because there's pluses and minuses in between. So I'm going to distribute that 2x. So I have 2x times x, which is 2x squared, and then 2x times negative 1 is minus 2x. Okay, combining like terms, I end up, let's see if my smart board will cooperate with me here. All right, let's see, try it again. Yes, okay, so I have x and I have a minus 2x. Oh, but I want to write this in descending order, so I'm going to put this term first. I have 2x squared on the top. 1x minus 2x is minus x, and then I have minus 3. Now, in the denominator, I have x plus 4, and times x minus 1. Okay, and we are done with the adding part, but now we should see if we can simplify this numerator. Can we factor that? Let's look at that. We have 2x and x to get 2x squared, and then factors of, we need a negative 1x in the middle, and factors of negative 3 that will allow me to do that would be 1 and 3, and if this is plus 2x minus 3x, that would give me the minus x in that middle term. And then on the bottom, I have x plus 4, and then x minus 1. And in order to simplify this completely, what we need to do is look and see if there's any common factors in the top, in the numerator, with common factors in the denominator that we could simplify. But there aren't any matching factors. I have an x plus 1 here and an x minus 1. Those are not the same, so we can't do anything with it. And that would be your final solution, or your final, that would be the simplified version, or you can leave it like this because that wasn't going to simplify anymore. Okay, Another example, and this time I'm going to be subtracting two fractions. And again, if you're subtracting, you still need to find the least common denominator, and then you subtract the numerators. You have to be careful that you subtract the entire second numerator from the first one, and I'll go over that in more detail in a bit. Okay, first thing we want to do is find the least common denominator, and in order to do that, we're going to factor both denominators. This factors into x, and factors of 4 that add to negative 4 that add to positive 3 would be plus 4 and a minus 1. The denominator on the right side is already factored. X plus 4 is a linear factor, and so it doesn't factor any further. So my least common denominator, the denominator on the left side, is x minus 1 times x plus 4. It's going to be part of my denominator. And then you look and see on the other denominators, is there anything missing? No, we already have the x plus 4 right here, so you don't need to repeat that. You could, but then it wouldn't be the least common denominator. So on the right side, on the left side, I have x minus 3 over x minus 1 times x plus 4 minus, on the left, did I say that right? The left side is x minus 3 over x minus 1 times x plus 4. The denominator is good because that is the least common denominator. But if you look on the right side, I have x plus 4 in my denominator, but I'm missing this piece right here. So therefore, I have to multiply the top and the bottom by x minus 1 over x minus 1, which is really multiplying by 1 because they simplify to 1. All right, so now I have my common denominator. That's going to be my denominator. Even though they're in reverse order, it doesn't matter. It's multiplication. You can switch those around. So my denominator is x plus 4 times x minus 1. And in the numerator, I have x minus 3. And then I'm subtracting this entire numerator on the right. So let's simplify that. The denominator is x plus 4 times x minus 1. And I have the x minus 3. Minus, I have to distribute that negative 2. So negative 2x times another x is negative 2x squared. And a negative times a negative becomes plus 2x. Combining like terms, on the top I've got a negative 2x squared, and I'm writing it in descending order. I've got a positive x here and a positive 2x here, so that's plus 3x minus 3 over x plus 4 times x minus 1. The numerator is not factorable. Well, you could try it, but I don't think you're going to find that it's factorable, and I don't think that it would simplify anymore. So we are done. All right, so that is how you add and subtract rational expressions. You got to find that common denominator. Come see me if you need help with finding that least common denominator, and we'll work on that. Okay, this next little piece here, we're going to also be looking at how to take a complex fraction, which means really it's when you have a fraction within a fraction. You are going to simplify that. And so here's some examples of some complex fractions. You got x plus 2 over 3 plus 3 divided by x. So we have that fraction within the entire fraction. Same thing here, we've got a 1 divided by x within a fraction. So, and this is a fraction divided by another fraction. So let's look at how to simplify that. Let's leave out the variables at first. Here we have 2/5 divided by 3/4. And divided by, the fraction bar means divided by, so we can take that 2/5 and write divided by 3/4. And when you have divided by fractions, you leave the first fraction as is, and you flip and multiply the second. So it would be times 4/3. And so then you multiply straight across, you get 8 over 15, and boom, you are done. And so now we have a simplified fraction. Started out with complex, now it's simplified. Okay, positive video, write this complex fraction down, and then we're going to simplify it. So we have this fraction divided by this fraction, same concept. We're going to write it as a division problem with the fraction in the numerator divided by the fraction in the denominator. And then again, you're going to flip that. You're going to flip this second fraction, and we're going to turn it into multiplication. Now, this is x plus 2, that whole quantity times x plus 5. So I'm going to put these guys in parentheses like that. There aren't any common fractions, any common factors, so there's nothing that we can simplify. So this could be the final answer, x plus 2 times x plus 5 over x minus 1 times x minus 3. Or you might see this FOIL. Maybe it depends on what answer key you're looking at, really. So x squared plus 5x plus 2x plus 10 divided by, in the denominator, x squared minus 3x minus x plus 3. And then I'm going to combine the like terms, so x squared plus 7x plus 10 over x squared minus 4x plus 3. And done. Okay. So why don't you pause the video and try to do this problem, and I will come back and work through it. Okay. All right, so hopefully you wrote it as a division problem, and then we're going to flip the second fraction and turn it into multiplication. And now let's simplify this. So we have x plus 1 times x minus 1. In the denominator, I have x squared minus 1, and I hope that you guys are starting to recognize that that is a difference of squares, and that's going to factor into x plus 1 times x minus 1. So if I rewrite this numerator, multiplying across, I have x plus 1 times x minus 1. And then in the denominator, I have x plus 1 times x minus 1. That's the x squared minus 1 in the factored form, times another x. Now, let's simplify this by finding common factors. I've got an x plus 1, and I have an x minus 1 that simplifies to 1 over x, because x plus 1 over x plus 1 simplifies to 1 over 1, and this also simplifies to 1 over 1. The x, notice that the x is in the denominator. A common mistake, a common error that I see often is that you have just an x left over, so a lot of students will say this equals x, but it's not x, it's 1 divided by x. There's still a 1 in that numerator, so it doesn't all of a sudden jump up to the numerator, so you want to make sure that you don't make that mistake. Okay, so that's the simplified version of a pretty complex fraction at the beginning. So let's see here. Then there's some application of this, but we will, I'm going to skip this for now. I'll come back with another video on this for Friday.